Okay, good morning. So, we are looking at Poisson distribution yesterday. Quickly, you'll recall what was the Poisson distribution. So, Poisson distribution is actually the limit in the Poisson distribution. The probability of success is very small, which means that uh, the limit p tends to 0 because the probability of success in this case is becoming smaller, and the other one says that okay, number of trials are very large, which means that n tends to infinity. So if we take these limits in our binomial distribution, we should get the Poisson distribution, and hence it is called the limiting case of the binomial distribution. The probability mass function for the Poisson distribution, e to the power minus z, z raised to r upon r factorial. So where r is some number less than the number of trials, and otherwise it is actually equal to 0. Where z is nothing but the mean, the formula for the mean n into p, which is also equal to the variance. The standard deviation is under root z. So this is something that we have seen in the previous lecture. One example we have solved. Uh, we'll go ahead with another example now. Example: number of road accidents on a highway. During a month follows Poisson distribution with mean 5. Find the probability that in a certain month number of accidents number of accidents on highway will be: first one less than 3, second between 3 and 5, Third one, more than 3. Yes. So solution, is given that the mean of the number of accidents is actually equal to 5. And I think that's all it is needed whenever we are dealing with Poisson distribution. So what are we supposed to find? To find probability of x less than 3. Second, probability of 3 less than or equal to x is less than or equal to 5. And the third one, probability of x greater than 3. What is the first answer? Probability of x less than 3. This is going to be probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So this is going to be summation e to the power. Yes, quickly, what is the probability? What will be the summation here?
Summation e to the power 5 into uh,
Ritika?
Yes, sir.
Yes, summation. Where is Sakshi?
So actually, I didn't attend the class yesterday, so I don't know about it.
I don't know about that. Shubham Kulkarni?
Yes, sir.
Yes, summation.
Sir, summation z, that is 5 to the power uh, r
R
into e to the power minus 5
e to the power minus 5
upon r factorial,
upon r factorial
and r is running from 0 to 2.
0 to 2. Yes, thank you. Very good.
Yes.
Yes. The final answer for this is
Sir, I think it's 0.124.
Exactly, it is correct. Probability of 3 less than or equal to x is less than or equal to 5. So that is going to be summation e to the power minus 5, 5 raised to r upon r factorial. R is running from 3 to 5. So that is 0.4913. You can check it later. The next one, probability of x greater than 3 is equal to
Sir,
1 minus probability of x less than or equal to 3. Yes, Saurav.
sir, in the second one, r is equal to 3. Then did we substitute that in r factorial and in 5 raised to r also, because that's the limit?
Yes.
Okay.
So this is going to be probability of x strictly less than 3 plus probability of x equal to 3. We have the probability strictly less than 3, so I'll put that value directly. So this is equal to 1 minus in bracket 0.124 plus this is 0.1403. So the final answer that we get is 0.7349. There's one different type of example which is yet to be considered, and that's why I'm in need of taking this third, or else I would have gone to the another type. The question is 2% of the product manufactured is defective. Is defective. If the product, if the product the number of is packed in a box of 100, and guarantees that not more than 5 are defective. In a box. Find probability that box will fail to meet guaranteed quality. Yes, what is the value of Z? Just because of this Z, I am taking this example, or else Poisson was almost clear to everyone. So in a box, there are 100 units, I mean, put in a box, out of which 2% are whatever product is, I mean, produced, 2% are defective. Okay, so in this case, instead of giving the mean directly, what they are giving you is the number of trials and the probability of success. So there are 100 in a box. The probability of success, the success being a product to be defective, it is 2% is defective. So 2 upon 100, 0.02. By the previous knowledge, Z is equal to N into P. So that is 2. Now they guarantee that not more than 5 are defective in a box. So if if a box fails to meet the guaranteed quality, it means that it should have uh, more than 5 defectives. But in that case, we will have 1 minus probability of x less than, oh sorry, not to meet the quality, x greater than 5. So this is 1 minus summation e to the power minus 2 into 2 raised to r upon r factorial. R is running from 0 to 5. E to the power minus 2 being constant, you can take it outside, or whatever you are, anyhow you are going to do the calculations on your calc. No point of simplifying here. So the final answer is going to be 0.0165. So that's all about the Poisson distribution. Next, another distribution is just I will just give the probability mass function for this, and we'll move on. So the name is uniform distribution. So let X be a discrete random variable taking values one, two, up to n. X is said to follow a discrete uniform distribution. If its probability mass function is given by is equal to 1 by n for x is equal to 1, 2, dot till n, and it is equal to 0 otherwise. Yes, why it is called uniform? Anyone who can think over it?
Each element could have a similar probability.
Similar or equal?
Equal probability, yes. Equal.
Yes. Any example where you can see uniform distribution of probability? Tossing of a coin. Okay. So example, X denote the number on face of unbiased die. So probability of x equal to x is going to be this when x is equal to 1, 2, 3, 4, 5, 6. Yes. What will be the probability? One by 6. I hope it is clear why it is 1 by 6. The next one, the geometric distribution. So let x be a discrete random variable taking values from 1 to n, say. Okay, then the probability mass function for the geometric distribution will simply be given by, so let x be a discrete, let x be a discrete discrete random variable then the probability mass function for geometric distribution is given by, so p of x equal to x is equal to 1 minus p raised to x minus 1 into p, where 0 is less than p is less than or equal to 1. Now p is the probability of success, 1 minus p is the probability of failure. Okay, so p probability of success. So this can also be written as, anyone?
Q raised to x minus 1 into p.
Q raised to x minus 1 into p. Just two ways of writing this. This this was the last discrete distribution that we have seen. The variance and the standard deviation is yet to discuss. So what will be the mean for the uniform distribution, anyone? Don't know. What is the expectation of x? What was the formula? Let me just write it down somewhere. If x is a discrete random variable, then expectation of x is given by
NP.
n into
P.
p. That's it.
No.
N into p. That's it.
No.
No.
Just
Summation x into p. So for uniform distribution x, what is the probability? 1 by x. This two will get cancelled out. So the mean for the uniform distribution is n. Variance variance first of all, is the mean clear? Is it correct? Or there is something wrong, Manas?
सर मीन 1 होना चाहिए ना
1 upon n होना चाहिए. Okay. So this has to be 1 upon n. So x is running from 1 to n. Okay. So what will happen is 1 by n being constant will come outside summation x. X is running from 1 to n. What is this? Summation so sum of first n natural numbers
n into n plus 1 by 2.
n into n plus 1 divided by 2. So the mean of the uniform distribution is n plus 1 by 2. Even yesterday I was discussing the mean of binomial distribution, the mean of Poisson distribution. In each of the cases you need to use this formula. This we have discussed the day before your Diwali vacation. Fine. The mean of uniform distribution is n plus 1 by 2. The variance of uniform distribution can someone tell me the formula now? Expectation of x square minus expectation of x whole square. This was the formula. I'll directly give you the answer for this. N square minus 1 divided by 12. I'll surely ask you the proof somewhere for this. This will be homework now. Homework. Mean, comma, variance for geometric distribution. There was one thing which I want to bring to your notice, that in the geometric distribution, if I mean, if I'm giving you that x, some experiment follows geometric geometric distribution, distribution, and I want to find probability of x equal to 1, considering that that 1 is in our range set of x. So how many values do you need to find this? So what things do you need if you want to find the probability of x equal to 1 where x is following the geometric distribution? Yes, anyone? Khushi? What values do you need if you want to find the probability of at certain point in geometric distribution? Manas?
Yes, sir.
Yes. What values do you need if you want to find the probability at certain point in geometric distribution?
Um, the probability of the
Success.
success for that success is success for that
That's it.
point.
That's it. You didn't need anything else, or that will be enough.
That will be enough in this case because
Yes. Yes.
x is equal
Exactly. So this kind of things are called the parameter. Okay. In the first lecture too, I said that x follows binomial distribution with parameters. Okay. So what do we mean by parameter? A parameter is very important point, and that's why I'm discussing it. Uh, for each distribution, you will have certain parameters. Okay. I'll write it down here. What is a parameter? Term which completely defines the probability distribution. Probability distribution. So in the first case, in geometric distribution, P is a parameter. In uniform distribution, what is the parameter?
N,
the number of
N.
elements.
number of
Yes, N is the parameter. In Poisson,
mean and X,
mean and x, is the mean.
Probability of success and X.
Do we break it down to NP?
Yes, n into p. Mean is actually n and p. So in Poisson distribution, there are two parameters: the number of trials and the probability of success. N, comma p. There are two parameters. And the fourth one, binomial. Again, in binomial distribution, there are two parameters. So that's why this is some notation which can be used. So x
Sir,
follows, wait, geometric distribution with parameter p. So this can be read as x follows geometric distribution with parameter p. X follows uniform distribution with parameter n. The third one, x follows Poisson distribution with the parameters n comma p. The last one, x follows binomial distribution with n comma p. There are similarly many other distributions. What was you asking, Saurabh?
sir, in binomial distribution, Q cannot be a parameter.
Can you find out q from the value of p? If p is
Okay.
given to you, can you find q? Yes.
Yes.
Then
Okay.
then it is not the parameter. Okay.
Okay. Means only those values will come for binomial in which we can calculate.
No. Which will completely define your distribution.
Okay.
Uh, Another thing now, if you look at the distribution, uniform distribution that I said, in this case, I said that discrete uniform distribution, So a uniform distribution can be for the continuous random variable too. Okay, remember that. And that is the reason why it is defined here, discrete uh, uniform distribution. Before we end up today's lecture, just one homework. Find cumulative distribution function for all the above probability distributions. So you can do this now.